Section 8.4, Multiplicative Inverses of Matrices and Matrix Equations. The n by n square matrix with ones down the main diagonal from upper left to lower right and zeros elsewhere is called the multiplicative identity matrix of order n. These are examples of these identities. Notice that the diagonal has ones. Everywhere else it has zeros. So a 3 by 3 matrix, you have ones on the diagonal, should be a 1. And everywhere else would be a 0. Let A be an n by n matrix if there exists an n by n matrix A inverse such that A times A inverse is equal to the identity matrix, and if we reverse them, A inverse times A is also equal to the identity matrix. Then we say that A inverse is the multiplicative inverse of A. If a square matrix has a multiplicative inverse, it is said to be the invertible or non-singular. If a square matrix has no multiplicative inverse, it's called singular. So for example, if we want to show that B is a multiplicative inverse of A, then what we need to do is multiply A times B and so if we multiply this, we have 2 times 1 is 2, 1 times negative 1 is negative 1. If I add those, 2 plus negative 1 is 1, 2 times negative 1 is negative 2, and 1 times 2 is positive 2, so that gives me a 0. 1 times 1 is 1, 1 times negative 1 is negative 1, so 1 plus negative 1 is 0, and 1 times negative 1 is negative 1, 1 times 2 is positive 2, and so you can see here that we get the identity matrix. However, we also have to multiply B times A, so if we multiply B times A, we get 1 times 2 is 2, negative 1 times negative 1 is negative 1, so that gives me a 1. 1 times 1 is 1, negative 1 times 1 is negative 1, that gives me a 0. Negative 1 times 2 is negative 2, times 2 times 1 is 2, so we add those, we get 0. Negative 1 times 1 is negative 1, plus 2 times 1 is 2, so that gives me a 1. So you can see here that they both give us the identity matrix, so we say that B is the inverse of A. Okay. So there's two ways to find the inverse of a matrix. One way is to take a matrix. For example, if I had 1, 2, 1, negative 1, and attach the identity matrix and use row operations. And our goal is going to be to end up with the identity matrix on this side. And so this part here would be your inverse. Okay. So that is one way to get your identity matrix. However, we're going to focus on a quicker method. And this method only works for a 2 by 2 matrix. And so it says if A is equal to A, B, C, D, then the inverse is given by 1 divided by AD minus BC. Notice what happens in the matrix here. The D and the A are switched, and then the B and the C, we change the signs. If we multiply AD and subtract B times C, if we get 0, then that means that the matrix does not have an inverse. So for example, if we want to find the inverse, I'm going to use the formula. So for us, our A is 3, and our D is 1. Our B is negative 2, and our C is negative 1. We're going to switch the A and D, so I'm going to have D on top here, and A on the bottom right corner. And then I'm going to change the sign, so -2 will become a +2, -1 will become a 1. Simplify. 3 times 1 is 3. -2 times -1 is +2. 3 minus 2 is 1. And finally, 1 divided by 1 is 1. So my inverse is 1 times each of these elements. So we get 1, 2, 1, and 3. Example 3, find the inverse. So we get 1 divided by 2 times 1 minus 1 times 1. We're going to switch A and D. So I have 1 here, 2 here. Change my signs, -1, -1. 2 times 1 is 2, minus 1. And 2 minus 1 is 1. So 1 divided by 1 is 1 times the matrix will come out to 1, -1, -1, 2. So example 3, find the multiplicative inverse of A equals 1, 0, 2, -1, 2, 3, 1, -1, 0. So again, one way to find the inverse here would be to attach an identity matrix and then use row operations so that the identity matrix is listed first. And the second part would be your inverse. However, to save time, we're going to use, for anything that is greater than 2 by 2, we're going to go ahead and use a calculator. So this is a 3 by 3 matrix. So if you have the calculator, a TI 8483, then this is how we would input it. Remember, if you don't have a TI 8384, I did send out a video on how to download this calculator that I'm displaying on my screen. So we're going to press on. We want to input our matrix, so I'm going to go second matrix, and I'm going to go ahead and press edit, and this would be a 3 by 3. I'm going to enter the numbers, so 1, 0, 2, -1, 2, 3, 1, -1, and 0. So then I'm going to go ahead and quit, so I can quit, go back to matrix. And now I want to do some math with this matrix. So I'm going to go to math, and I'm going to go to, actually, what you can do is let's call that matrix. So I want to use A, so I just press enter, and it comes to your screen. So to find the inverse, you're going to use this X inverse key. So I'm going to click it, press enter, and so that would be your inverse. So my inverse is 3, -2, -4, 3, -2, -5, -1, 1, and 2. You can use the calculator to check your work for a 2 by 2 matrix if you like. Okay, so for example, if we look at our previous example, then I would go to second matrix, and I'm going to edit. I'm going to use letter B. Oops. Second matrix, edit. We want to use B. This is a 2 by 2. And so I'm going to go ahead and enter this example here. So we have 3, -2, -1, and 1. So I'm going to quit second matrix. Now I want to use letter B. Enter, use the inverse key, X inverse. And so you can see that we get 1, 2, 1, 3. Okay, so that's a way to check your work if you're using this formula. So the idea of the inverse really comes down to what can we do with this inverse, and we can use this inverse to solve a system. So we've been solving systems since chapter 7, and you learn different ways. For example, you use the substitution method, addition method. We use Gauss elimination in chapter 8. So this is just another way of using an inverse to find the matrix. To solve a system, we need X is equal to A inverse times B. So the first thing you want to do is, from your system, create a matrix A that consists of coefficients. So we have 4, 1, 1, -1. You need a matrix B, which is the constants, 2 and 3. And then we're going to need A inverse. Okay, so to find A inverse, I'm going to use the formula. So we have A inverse is equal to 1 over 4 times -1 minus 1 times 1. Switch the A and D and switch the signs. So we end up with 4 minus 4 times -1 is -4, minus 1 is -5. Multiply -1/5 into the matrix. So we get positive 1/5, positive 1/5, positive 1/5, and -4/5. Okay, so my inverse is 1/5, 1/5, 1/5, and -4/5. Once you have your inverse, then to solve the system, we're going to multiply our inverse times the matrix B. So my inverse here is 1/5, 1/5, 1/5, and -4/5 times B, which is 2, 3. You can use your calculator to multiply this out, or you can just multiply it. So 1/5 times 2 is 2/5. 1/5 times 3 is 3/5. 3/5 plus 2/5 is 5/5, which is 1. 1/5 times 2 is 2/5. -4 times 3 is -12/5. Plus the 2/5 gives me a -10/5, which comes out to -2. So our solution for this system is X is equal to 1, -2. But what does that mean? X is just your variables. So in this case, X is equal to 1 and Y is equal to -2. So that's going to be your solution. Yep. So using the inverse is just another way to solve a system. So let's look at example 4. It says solve the system by using A inverse, the inverse of the coefficient matrix that you found in example 3. And so let's just make sure that our matrix is the same. -1, 2, 3, 1, -1, 0. Okay. So here my matrix A is 1, 0, 2, -1, 2, 3, 1, -1, 0. And if you notice, this matrix is the same as the matrix we used up here. And then we're going to need a matrix B, 6, -5, and 6. And then we need an A inverse, which we already found in example number 3. So that was 3, -2, -4, 3, -2, -5, -1, 1, and 2. So to solve, we use x equals A inverse times b. So I'm going to go ahead and write it over here. 3, -2, -4, 3, -2, -5, -1, 1, and 2. And we're going to multiply that times b. I'm going to go ahead and use the calculator for this. So recall that I already have my matrix A in here. So first thing I want to do is enter my matrix B. And I'm going to go ahead and edit matrix B. And this matrix B is a 3 by 1. And the numbers are 6, -5, and 6. So both matrices are in here. So what I want to do is I'm going to find the inverse of A. Oops. So it's important to quit, second quit. So second matrix, I'm going to call A. And I'm going to find that inverse. And then I'm going to multiply it times matrix B. So we can set it up this way, and then we press enter. And so that comes out to 4, -2, and 1. So what this tells me is my answer here is going to be x is equal to 4, y is -2, and z is 1. Okay. So that is solving a system using the inverse of a matrix. The last part of this section is to encode a message. Okay. So if you want to encode a message, for example, the word base. So a long time ago, in one of the wars that people would use matrices to encode messages. Then that quickly got discovered by other places, so they changed their way of communicating. But encoding a message is a way to communicate with others without people knowing what you're writing. So to encode a word or a message, the first thing you want to do is assign a number. Okay, assign a number to each letter in the alphabet. Okay, so for example, if we have A, B, C, D, E, F, and so on, A would be 1, 2, 3, 4, 5, 6. So A is 1, B is 2, C is 3, D is 4, E is 5, F is 6. And we can go all the way to Z. And then we have a space. So for space, we use 27. Okay. Once you have that, then you're going to create a matrix with those numbers from step 1. And you want to create a matrix that you can multiply with the encoding matrix. Okay, so number 3 would be to multiply the coding matrix with your matrix. So in order for this to work, only certain people can know this coding matrix. So for example, if I was sending a message to you, then only you and I would know this matrix. Otherwise, then people can figure out our message. Okay, so then we send the message to the other person. Okay, so let's look at this example. So I already have the numbers listed for us in this example. So if you need a space, remember this is 27. So if we want to encode the word base, then B is going to be 2, A is 1, S is 19, and E is 5. Okay, so that's your first step, is assign a number to the letters. Next, we're going to create a matrix. Since this is a 2x2 matrix, we want to make sure that whatever matrix we create from here, it's also going to be 2x2, or not 2x2, but 2 by something else. And you always want to remember how you enter these numbers into your matrix, and the person that's receiving should also know how you entered those numbers. So those are things that would be discussed before you actually encode with your friend. So here I'm going to create a new matrix, and I'm going to go down on this matrix. So I'm going to start with 2, and then my next letter would be below it, and then 19 and 5. If I had more numbers, then I can just keep putting them in here. So now my matrix is -2, -3, 3, and 4. That's my coding matrix. And I'm going to multiply that times my new matrix, 2, 1, 19, 5. And I'm just going to use a calculator. So I'm going to go second quit. So second matrix. And I'm going to edit the first one. So we want to edit A. This would be a 2x2. And A is going to be my coding matrix. So -2, -3, 3, and 4. Second quit. Then I'm going to use B. 2x2. And the numbers here are 2, 19, 1, and 5. Second quit. So I want to multiply second matrix A times second matrix B. And so the numbers I get are -7, -53, 10, and 77. So once you have your message there, then what you're going to send is this numbers here, and remember the same order that you entered them is the same order you want to take it out. So you have -7. The second number is the one below it, so we have 10, -53, and 77. So this message is what you would send to the other person. Now the other person is going to receive that, and in order for them to decode it, to know what it says, they need to find the inverse of the coding matrix and multiply the inverse times the new matrix from the message. And then assign letters to the numbers. Okay, so for example, this is the message that we just got up here. So somebody sent me this. So although I know my coding matrix is A, what I first have to do is find that inverse. Okay, so I'm going to use a calculator. Second matrix, A, I'm going to find the inverse. And my inverse is 4, 3, -3, and -2. So then we're going to take this inverse, 4, 3, -3, -2, and multiply it times a new matrix. So we can create a new matrix here. And again, you want to write this numbers the same way you would normally do. So I'm going down. And so let me input these numbers. So I need to create a new matrix over here. I'm going to go to C. And this would be a 2 by 2. And the numbers would be -7, -7, -53, 10, and 77. Second quit. Okay, so I'm going to multiply the inverse. So there's my inverse times my matrix C. And I get 2, 19, 1, and 5. So now we would take our answer here, and I'm going to write it as 2, 1, 19, 5. So this is BASE. So through email, I will send you a message, and you can decode it for extra points on exam 4. So on exam 4, decode the message sent through email for 5 points.